Hey everyone, today I'm going to be going into the advent of coding 2024 and trying to solve these questions. I'm not sure the difficulty level of these, but I hope that I can actually get some of these done. So it's day one of advent of code 2024, and I'll just walk you through how I'm going to solve this question. Haven't answered it yet. I literally just signed in, and I'm going to read over it and then try to solve it live for y'all. Cool. So, the chief historian is always present for the big Christmas sleigh launch, but nobody has seen him in months. Last anyone heard, he was visiting locations that are historically significant to the North Pole. A group of senior historians have asked you to accompany them as they check the places they think of he was most likely to visit. As each location is checked, they'll mark it on their list with a star. They figured the chief historian must be in one of the first 50 places they'll look. So in order to save Christmas, you need to help them get the 50 stars on their list before Santa takes off on December 25th. So collect stars by solving puzzles. Two puzzles will be made available on each day in the advent calendar. The second puzzle is unlocked when you complete the first. Each puzzle grants one star. Good luck. Okay, it's just telling you what the story is. So it's about a chief historian. You haven't even left yet, and the group of Elvish senior historians have already hit a problem. Their list of locations to check is currently empty. Eventually, someone decides that the best place to check first would be in the chief historian's office. Upon pouring into the office, everyone confirms that the chief historian is indeed nowhere to be found. These guys missing. Instead, the elves discover an assortment of notes and lists of historically significant locations. This seems to be the planning the chief historian was doing before he left. Perhaps these notes can be used to determine which locations to search. Throughout the chief's, my camera's kind of trash, but throughout the chief's office, the historically significant locations are listed not by name, but by a unique number called location ID. To make sure they don't miss anything, the historians split into two groups, each searching the office and trying to create their own complete list of location IDs. There's just one problem. By holding the two lists side by side, your puzzle input, it quickly becomes clear that the lists aren't very similar. Maybe you can help historians reconcile their list. Interesting. Interesting. There's a big mouthful. I shot like 6, 7 videos today, so my voice is literally on its last life. So maybe the lists are only off by a small amount. To find out, pair the numbers and measure how far they are apart. Pair the smallest number in the left list with the smallest number in the right list. Then the second smallest left number with the second smallest right number, and so on. Within each pair, figure out how far apart the two numbers are. You'll need to add up all of those distances. For example, if you pair 3 with a 7, the distance for it. If you pair 9 with 3, so we're pretty much like pairing the list, and then seeing which ones are smaller, or the distance between the two smallest, the distance between the two second smallest, the distance between the two third smallest. So an example above, the pairs distances would be as follows. So we have this example. It's always good to work through an example. So when you're solving leak code, when you're solving even advent of coding. So then within each, figure out how far apart two numbers are. You'll need to add up all those. This, for example, if you pair up 3 from the left list with a 7 from the right list, the distance 4. Yeah, I went through that. So what I'm thinking is like let's just sort both lists and then see how it looks. So we can like actually walk through the example. So this looks like the smallest, like sorted. So these are, okay, wait. So the smallest here is 1, then we have 2, then we have 3, 3, 3, 2, 3, 3, So we have 3 threes, then we have a 4, right? Now what do we have here? We have 3, 3, 3, 4, 5, 9. Cool. So the smallest number in the left list and the smallest number in the right list is 3. So the distance between them is 2. Distance between this is 1. Distance between this is 0. Distance between this is 1. So yeah. Here 2 and here is 5. You could see that that lines up. So to find the total distance between the left and right list, pretty much just like add them all up, and that's how they get 11. So what I'm thinking is we will just create 2 lists, right? The left list and the right list. And then what we're going to do is we're going to loop through the input, and then we're going to pretty much build these lists, the left and right list. Then we're just going to sort these 2 lists. Then we'll just like compare every single element of the left list with the, like, since they're going to be ordered correctly, then we'll know, like, if we look at the 0th element, so pretend we get like 1, pretend these are like randomly ordered, but we somehow parsed them into the left and right. Now when we sort them, we pretty much get like 2, 3, 4. Then we get 1 or negative 1, 1, 2. And now we pretty much can just like compare. The 0th index would be the 2 smallest. The first index on both would be like the 2 second smallest. And then we just add up those differences. So let's write this code. Let's just use their example, because the input is gonna look something like this. Makes sense. So let's say the input looks like something like this. Input let's say, so to parse the input, let's get input, this is the input string. We're gonna want to parse the input. So to do that, let me just move this, flip these over now. We're gonna do a lot of coding. So we're gonna do, this is a decent question for today, nothing too hard, like a little warm up. Input array equals, take the input string, and then you split that by the new line. Print. Let's see how this looks. Terminal. Python 3, day 1. Okay. And then we're also going to want to grab just the 0th element to the negative 1th element, because the new lines at the end, I want to skip those. And then what we're going to do is, we're going to get final result, or final distances. I guess we don't need that right now, but like I said, we're going to build a array of the left and right columns. So let's do left and right equals like this, doing everything in Python. For element in the input array, what I'm going to do is I'm going to grab the left element, the right element. I'm going to take the element dot, I'm going to split by that. I'm going to take, in the left, I'm going to append the left element. In the right, I'm going to append the right element. And then let's just make sure we print the left and the right. And that should like get all like the specific columns in what we need. So 3, 4, 2, 1, 3, 3. 435393. And then after, what's it called? We're going to want to sort these. So let's say left dot sort, right dot sort. So now we have those sorted, and now we just need to compare values. So for do that, we'll just say for I in range, the length of it could be the length of the left or the right. It doesn't matter because they're all the same. What we're gonna do is we're gonna compute the distance, and that's pretty much like total distances plus equals the absolute value of the left I minus the right I. And then we'll do print total distances. We'll say the total distance is total distances left I minus for I in range length left. Okay, what is it saying? Okay, let's convert these to integers. It's complaining about that they're a string. Cool. Now we got 11, and basically from right here we say the total distance is 11. That's correct. Sorry, I'll keep myself on this right corner. Get your puzzle input. This super big list. Maybe there's like timeouts or something. Maybe it needs to run really fast. That looked like very, very fast to me. Submit. Boom. That's one gold star. On to the next one. Cool. So the first half of the puzzle is complete. It provides one gold star. Part 2. Your analysis only confirmed that what everyone feared. The two lists of the location of these are indeed very different. Or are they? The historians can't agree on which group made the mistake or how to read most of the chief's handwriting. But in the commotion, you notice an interesting detail. A lot of the location IDs appear in both lists. Maybe the other numbers aren't location IDs at all, but rather misinterpreted handwriting. This time, you'll need to figure out exactly how often each number from the left list appears in the right list. Calculate the similarity score by adding up each number in the left list after multiplying it by the number. Okay. So, let me write this down. Getting a little bit more complicated. It's a massive input. What I'm going to do. So we're saying, we're going to say, a lot of locations appear in both lists. Maybe it's just in misinterpreted handwriting. Cool. Write that down. That's information I need to know. This time you'll need to figure out exactly how often each number from the left list appears in the right list. Okay. Calculate it by adding up each number in the left list after multiplying it by the number of times it appeared in the right. Okay, so we need to get a frequency count of each number from the left list. So, okay, first, get all elements from the first list. Second, get a count of get frequency count of how many times it appears in the right. Right. Here are the same example list again. And then after adding up each number in the left list after multiplying it by the number of times that number appears in the right list. Okay, so we just multiply the number by its frequency in the right. So the first number in the left list is 3. It appears in the right list 3 times. So 3 times 3 is 9. What happens if it's 0? Okay, if it's 0, it multiplies by 0. Cool. So how I'm going to do this is I'm going to use a default dictionary from collections for default dict. I'm going to grab a frequency counter. And then what I'm going to do is, or I don't even need to use a default dictionary. I can just use a regular dictionary. And what I'm going to do is, well, I need to get unique elements in the from the left. Unique left elements, right? And to do that, I'll just take the left. I'll be parsing it the same way, right? We're probably no longer care about the distances, but we will need to parse. So this is parsing input, but we're no longer calculating distances. That's part 1. So I'm grabbing the unique elements from the left by just taking the set of everything in the left. Then what I'm going to do is I'm going to grab a frequency counter, and I'm pretty much going to initialize it as an empty dictionary, and I'll say for every element in the left, frequency counter, add that element equals 0. So I'm pretty much creating a big dictionary where I'll be like 3 is 0. What other elements we have there? 1 is 0. Then I was saying 2 is 0. Like, these are the counts of the frequency. So I'm building the frequency counter, starting them at 0. And then what I'm going to do is I'm going to loop for element in the right. And then what I'm going to do is, like, if the elem is actually in unique elements, unique left, if the right element, like for example, if 4 is in the unique elements in the left, what we're going to do is we're going to increase the frequency counter. So we're going to say lm plus equals 1. That should print us a nice frequency score. Or that should print us the frequencies. Frequency for element in right. For element in left. If this element is in unique left elements, we should be looping through all these. What happened? Did I save? Oh, there's nothing in right. Why is that the case? Oh, because my input. Rookie mistake. Rookie mistake. Cool. So we could see for 3, it shows up, the right shows up 3 times. For 4, it shows up 1 time. Just verifying. For 2, it shows up 0 times on the right. For 1, it shows up 0 times. So, yeah. That's kind of what we have to do here. So what we're going to do is, like, we're going to take the result and we're going to start that from 0. And we'll say for element in the frequency counter, we're going to take the result plus equals the element multiplied by its frequency. And the frequency counter is based on the right frequency. And then we'll print out a result right here. The score is 13. So we have to multiply. Move this. Oh shoot. Oops. Why am I saying 13? Okay, the first number appears in the less list 3 times. The second number 4. Or the second number in the left list is 4. It appears. The third number. The fourth number. Oh, so we don't. It's not by unique. So we just pretty much for element in left. It's pretty much we just have to loop through it again. So this, since it appears 3 times, we multiply by 3. Since this appears 1 time, we multiply by 1. But even when we get to these ones, we have to multiply it by 3 again. So let's just put this massive input. And I hope that all made sense, and I hope this works without timing out. If it's timing out, I'll just optimize the algorithm. There's probably some ways to optimize it. Very, very large number. Boom. That's right. Answer. You are gold 1 star closer. You have completed day 1. Cool. Nice. And that's pretty much how you solve Advent of Code day 1. I'll see you all again on day 2. Peace.